10.3 Graphs of Trigonometric Functions. Let's see. In this section, we'll talk about the graphs of these three functions: y equal to sine x, y equal to sine x, and y equal to tangent x. Cosine and tangent. We'll test it later. And now we'll have a look sine. Before we start, do you remember the definition of trigonometric function? Yeah, if now we have a point P, the coordinates are x and y, with the length of OP r, then sine theta equals to y over r. That means this time we focus to the y coordinates, okay? And now we'll use a unit circle to explain the graph. Unit circle, that means radius equals to 1, okay? That means now here we use a circle for the radius equals to 1 and explain the graph, okay? Then let's have a look the change of y coordinates, okay? Let's go. Now here is a unit circle, okay? Here's 1, right? The length of the radius is 1, see? And we'll have a look y coordinates. That means the red line. What's the length of the red line, okay? So let's see. If now we started from 0 degrees, then what happened? 30 degrees. Sine 30 degrees equals to 1 over 2, so 0.5. How about 45 degrees? 45 degrees, 0.707. This one actually is root 2 over 2. Root 2 over 2. How about sine 60 degrees? Yeah, 0.866. That means root 3 over 2. Root 3 over 2. Then next one is sine 90 degrees. Do you remember? Yeah. Sine 90 degrees equals to 1. That's great. How about greater than 90 degrees? In the quadrant 2, sine theta is positive, right? But it goes down. Have a look. 120 degrees. Yeah. 0.866. Familiar? Yeah, root 3 over 2. How about 135? 135, 0.77, right? 0.707. Yeah, root 2 over 2. How about 150? Yeah, 150 sine 150 degrees, 1 over 2. How about sine 180? Yeah, 0 again. Okay. If it continues, goes on greater than 180 degrees, then quadrant 3 and 4. Do you remember the values of the sine theta? Yeah, these two quadrants all are negative values. So let's see. The y coordinate goes down. Yeah, okay. 210, negative 1 over 2. 225, negative root 2 over 2. 240, sine 240 degrees, negative root 3 over 2. Yeah, sine 270, sure, or negative 1. And then go back 300 degrees, negative root 3 over 2. 315, negative root 2 over 2. 330, negative 1 over 2. How about 360? Sine 360, that means sine 0, go back to 1. Right. So you see that from 0, started from 0, and then you can draw the graph. You see the blue one, we say that it's a sine curve, like a wave, right? So now you can draw this one by yourself. 90 degrees goes to the top, okay, right? Maybe I use the pencil, okay? Goes to the top, 180, 0, 270, -1, and then go back to 360. So try to draw the curve. Like this. Right. So this one as y equal to sine x. Here we use x because the x-axis, okay? If we write as theta, then you can say that y equals to sine theta, okay? Can you tell me which value is the maximum value of y? Very good. Here is the maximum point. Get the maximum value, 1. Which value is the minimum value? Good. This one is the minimum value. You get -1. Good. So you see that the range of sine x in between -1 to 1. -1 to 1. That means the smallest one is -1. The greatest value is 1. So let's see. How about the change of sine x in these 4 quadrants? Starting from quadrant 1 is increasing, right, from 0 to 1. How about quadrant 2? It's decreasing from 1 down to 0. How about the third one, quadrant 3? Yeah, you see, goes down from 0 down to -1. How about quadrant 4? Yeah, increase again from -1 comes up to 0. Okay? So this one, not difficult. And let's see. If we have a look, after 360 degrees, okay, just now we focus in between 0 to 360 degrees. How about we goes on? And you see that the graph goes up and down again, like this. So you see that from 360 to 720 degrees, that means this part, this curve, same as 0 up to 360. So they have the same figure, right? So that means this is the curve of the sine theta, okay? Hope you understand about the graphs of sine x. Next, we'll talk about cosine x.